Today, I'll be teaching you how you can subtract coalition shapes from your navigation polygons so that the pathing through the Navigation2D node becomes so much more smoother and you don't collide into any collision shapes anymore. Let's get started. Now, this tutorial is going to assume you have a little bit of knowledge of the Navigation2D node that I've already added right here under my node tree. Now, really quick recap, Navigation2D basically helps you to determine the path between point A and B at runtime. So whenever, for example, you click with your mouse somewhere on the map, you can steer your player from the current position to the position you want to go. However, the downside of this is that any coalition shape that is inside that navigation polygon instance that I've added here, this big green piece, any coalition shape inside that, the Navigation2D node sort of can't recognize. So if the path were to exactly cross a coalition shape, you'll have your object or your player bump into this coalition shape, and it rather looks silly, stupid, and well, you know, it's not what we want, right? We want the player to just move around that very smoothly. And we can do that by taking this navigation polygon instance, this big green thing that I already added, and we could add a simple extra polygon here, and it will recognize, okay, I have to cut that out. But doing that for every single chest and every single tree and every single building, you know, that's going to take a lot of work. And it's not very flexible. You want to change a tree a little bit, you got to redo your polygon. So it will be much quicker, much easier if you can cut out these cutouts. If we just call them a cutout, it will be much easier if you can cut these things out through the code based on the coalition shape that is, for example, on that tree or on this chest. Now you can do that. I'm going to learn you this in this tutorial, and I'm going to learn you this for both a StaticBody 2D. So we're going to take this railing here, this first railing of this bridge as an example, and we're going to take these chests as an example, which is an atlas tile under the TileMap interactables, and they are in an atlas tile, basically just objects with coalition shapes. So let's get started. Let's start with that StaticBody. Let's start with the bridge. So to get started, I'm first going to remove that hand-drawn cutout because, well, that looks silly, doesn't it? And we're going to go over to the code immediately because there's quite a lot of code to go over. So I'm not going to be typing anything. I'll be copy-pasting in line by line and discussing what we are exactly doing here. So I've written this code under the Navigation2D node. You can pretty much put it anywhere. But as we've already got quite some scripts from previous tutorials that we've done with this setting, I thought I would make a new script. So what we're doing under the ready function, I've prepared this just a little bit. We're calling the single use, so that's, let's say, a static body. You could of course also call this single use function in a loop or in a group. You could, for example, put every single coalition tree or static body that has a coalition shape in a group called, I don't know, coalition bodies. And you could simply say get tree, get nodes in group coalition bodies for every body, put them in single use, and then you can go over this single use loop just for every single coalition body. So that's how you could do that if you want to do a batch instead of a single one. Now we start off with a new polygon. This new polygon is going to be the new cutout, so the cutout that we want to deduct from the big one, and that is going to be a pool vector 2 array. That's basically an array specifically for vector 2s. Now, then we have a polygon, and the polygon is going to be the big green thing that I already draw. That's going to be the navigation polygon instance. So we get that instance and we get the navigation polygon from it, and we store that in the variable polygon. Then we need two more variables. And the first one is a polygon transform, and the second one is like a polygon blueprint, I called it. Let's start out with the blueprint. For the blueprint, we basically approach the node that's in the Y sword, in the bridges, in the bridge stone, and in the bridge stone we got a coalition polygon 2D. We actually got two, but just for example, we'll take one. So we get the polygon of the coalition polygon 2D node. With that get polygon, this function returns a pool vector 2 array. So you would say, okay, then why do we need any more code? We got the shape right there. Yes, we got the shape, but we don't have the transform. This bridge, for example, is actually scaled down with, I think, 30% or something like that. It's maybe rotated a little bit. It's of course not at 0, 0 global coordinates. It's somewhere else on the map. And all that information, the position, the rotation, the scale, that's all stored in the transform of that bridge. So that's why the polygon transform, we get that exact same polygon, collision polygon 2D, and we get the global transform. Remember, we need to get the global transform, because if we just get the transform, we get the transform in relation to the node bridge, because that is a instant scene. So we want to get the global transform, as that is what we can apply to the navigation polygon instance. So with that blueprint, which is a pool vector array, and that transform, which is a store, basically a container with a lot of things that we want to know, we can then say that for every vertex in the polygon blueprint, so for every point in the pool vector 2 array, in other words, we're gonna append the new polygon. So that's the pool vector array that we were going to be creating, the cutout. So we append the cutout with the polygon transform. That's a transform just stored there. The xform, the xform is the function that we apply that transform to something, and we apply it to the vertex. So with this, we're going to go over every vector 2 which is inside this pool vector 2 array, that is the blueprint polygon. We apply this transform, and every point that we have applied the transform from off, we then store in the new polygon. There, by doing so, the new polygon becomes the cutout, the polygon that we want to cut out. So to actually then add that cutout to the navigation polygon instance, we approach the polygon. So that is the polygon that we have stored through this function. We add the outline, so it's going to be the outline of the cutout, and we push the new polygon, the cutout we just created with the transforming stuff. Now once we've done that, we need to do one more thing before this becomes real, and that is we have to make polygons from outlines. That's basically a function which then says, okay, go do your thing with all these outlines, with all this data that we just gave you. Then of course we have to set the navigation polygon again equal to the polygon that we've just adjusted through this code, and with that done we can hit play, and you'll see I've dragged this collision or this navigation shape out a little bit so this will be more clear. But right here you can see that there's a shape missing inside the navigation polygon where that was previously continuous. And if we have a quick look at the scene of this stone bridge and we show the polygon instance, you can see that is equal to the shape of the collision shape that was stored in this collision polygon 2D. So with that, you now know how you can, through code, and you can even bulk or batch do this, you can cut out navigation polygons from a big navigation polygon. Thereby you can simply select your whole map like we have right here, and you can then go over every single static body that's on your map to make sure that that is no longer within your navigation polygon. Now of course this is just for static bodies. We also have these chests, and these chests, they also have collision shapes, but these are not static bodies, these are tiles. So with tiles we have to extract the collision shape through the tile map and the tile set. Now it works a little bit differently, so let's do that too, and then you have two tools by which you can make your navigation more smooth. Do you want to learn more about Godot? Subscribe to this channel and don't forget to hit that little bell icon to make sure you don't miss out on any videos. I also live stream the game development sessions I do myself in Godot on a title called Soul Whisperer. You can find me on my Twitch stream every Tuesday and Thursday. I hope to see you there one day, and now let's continue with those navigation polygons. So the tile set, let's get started on that. Let's first have a look at the tile set so you understand the code that I'll be showing you in a moment just a little bit better, a little bit quicker. We have this tile set here, and right here we got the 4 chests that are currently on the map. These are in a atlas tile, so that means that these are 4 tiles within an atlas tile. This specific ID is ID number 6. I so happen to know that there's a couple of functions which you can use to identify which ID is exactly which tile, but you got to make sure that you know this ID. This ID is very important. Now, if we want to get the collision shape of one of these tiles, if I select this atlas tile, I would show you the collisions. They're right there. We don't only want to know which of the collisions we need to get. We need to get, first of all, which tile is being used. Then once we know which tile is being used, we have to select that right collision shape based on the tile that's being used. Then this collision shape has a transform compared to this tile. So the tile is probably starting here at 0, 0. So this transform has a offset or a transform from that corner. And then, of course, the tile itself also has an offset from the global coordinate 0, 0 on the map itself. So we need to do a double transform here. So this is sort of the information we need to get out of here. So let's go over back to the code and let's see how that is looking. So under here, under the script, I made a couple of small changes. First, I saved the interactables, the TileMap node. I saved that node in a variable so I can easily reference it. And then here we don't only have single use like we just had, we also have tile use, and rename this function to however you see fit. And I'm pushing two variables to it. The interactables, the node where these tiles are living on, and the tile ID, number 6, that you just saw. Now, I could also be putting these variables hard in the code that we'll be adding right here on the tile use, but by actually making these variables that are being pushed, you can use this for anything. So if you also have, for example, a tile map for trees and a tile map for buildings and a tile map for something else, you can very quickly, with the same function, by simply changing these two variables input, you can very quickly deduct all those cutouts from the navigation polygon instance without having to change the code or having to copy a lot of code. So now to the tile use. So this is going to be receiving the tile map, of which it needs to be subtracting things, and the ID of the actual tile within the tile set of that tile map. We again start with, well, actually here we started with a new polygon. That's going to be coming down a little bit later. We start again just like we started here by retrieving the polygon from the navigation polygon instance. So that's nothing new. Then what we do is we have to make sure that we know where this tile is exactly being used. Where are we using these chests? So we're going to go we create a variable, use chest tiles, but you could also cut out the word chest to make it more variable and less specific to the use case that we have here. Therefore, we go to the tile map. So basically what we do with this tile map is this interactables, is this node. So basically we're just going to get the node, the tile map, and we're going to get use cells, and we have to input the ID of the tiles that we want to verify if they're being used. So that's where this 6 comes into play, because that's being turned into the variable ID here, and that ID we then push into that function. We've used this function specifically before in one of the previous tutorials on interactive tiles, how you can make tiles or change tiles at runtime. I'll put a link down there in the description if you want to get more information on how it exactly works. Then what we do is that for every tile in used chest tiles, because there's, I believe, 7 chests on the map, there's also a couple in the distance. So we want to get, for every tile in used chest tiles, we're going to create a new polygon, because for every single one of those tiles, we're going to create a new cutout. So that's why we put the pool vector to array. Basically, this is exactly the same line of code as here. That's why we put this one a little bit later and not right at the beginning, because we want to iterate over every tile that we have in that tile map. Then basically we get 2 new variables. These we're not getting here, so these 2 are new. First, we get the polygon offset. Basically, that is the offset from the global 0, 0 to where the tile actually is. For that, we use the function map to world. So we can go to the tile map. So it's again that interactables, that very tile map right there. We take the map to world function and we put the tile in as input. However, we have to do something extra, because this is going to get the corner of the tile, and we want to have the middle of the tile, because that's important for where we exactly have to put this coalition shape. So we're going to subtract the vector2 TileMap get size, and then the first vector part, the x part, divided by 2 and 0. Now, what does that mean? What does that mean? Basically, we create a new vector2, and we create a new vector2 by using the TileMap get cell size. So if we go to the interactables, to the inspector, we actually get this 64 by 32. If we hover over size here, you'll see that's the cell size that we've been using in this script. So we get cell size, and then the get cell size retrieves a vector2, but we don't need everything of this vector2. We only need the x part, and we actually only need half of the x part. And the y, we don't need it all. That can just be 0. But that's specifically why, because I'm working with isometric art, so you might have to fiddle around a little bit to see what you need for forward angled art or top down art if you're working with that one. But use this function and make sure that they overlap, and I'm pretty sure you'll figure that out pretty quickly. So for my case, I'm going to get the first entry of this vector 2. So remember, this retrieves a vector 2. So with this between bracket 0, I'm going to retrieve the x, and then the x I'm going to divide by 2 because I need that the midpoint of x. Then for the y, which is 32, I'm not going to use that at all. I'm just going to hard push a 0 to it. That's how I'm putting the offset of this polygon exactly to where I want it to be. Now, once we got that offset, we also need to get the tile region. The tile region is where the specific tile that's being used from this tile is within the atlas tile. Remember, we had 4 chests, and we need to know which chest of these 4 we're currently dealing with to know which of the collision shapes we need to select. So we're gonna use another function for that. That's the get cell auto tile coordinate. It says auto tile, but it works for atlas tiles too, don't worry. So we go to TileMap, we use that function, and that is going to retrieve us a coordinate, and we need to put in a x and a y, and that is actually the x and the y of the tile, because this function get used cells by ID is going to return the tile by its tile grid coordinates. So not the global coordinate, not the xy coordinate, but the xy grid coordinate. Also in that description, there's a link to that interactive collision shapes. I explain all about this. So once we have that, we can then get the tile transform and the polygon blueprint. So that's pretty much these 2 functions, but then of course making use of the tile set. So for the tile transform, we're going to go into the tile map. We're going to get the tile set resource that is on that tile map. Then we're going to get the tile get shape transform. We have to put in the ID, so that's again ID number 6. And then we have to get the tile region, or we have to get the X, because this is a get shape transform allows you to determine which shape we want to get. So actually that atlas tile that has 4 shapes, we can't select it by region. We have to select which shape of that atlas tile we want. But since each and every chest only has 1 collision shape, we know that region number 1 is shape number 1, region number 2 is shape number 2, etc., etc. So we know that with this get cell auto tile coordinate is going to retrieve as a vector 2. That vector 2, for example, if we have chest number 3, that vector 2 is going to be 3, 0. You know, 3 on the x-axis, 0 down, because it was only a stroke of images, not a stroke of chests. So we're going to retrieve the x, so it's going to be 3, for example, in that case, and that's going to be retrieving the 3rd shape of that tile on that tile set, which is on that tile map. Yeah, are we following? Yeah, we're following, right? Okay. Now for the next one, the polygon blueprint is pretty similar. We get the tile map, we get the tile set resource, we get the tile get shape, and that again requires a ID and a which shape you want. So the shape ID, so it's going to be, for example, with chest number 3, that is 3, and we get that through this function. And we get the points. Now it's important, we don't get the polygon like we do here, we get the points, and that's because the get polygon doesn't work on a convex shape that I've drawn on these, or I don't know, they're just a little bit different, so I had to change the code or the function that we're actually using where the get polygon is not available. I'm not sure what it was, but for a tile map, use get points and you'll be fine. Then what we do is basically the same as we do here, but this time we have to do 1 step extra, because we don't only have a transform to deal with. And again, this function, this line of code is exactly the same as this one. Only what we do extra here is we also, this is a vector 2, of course, this vertex, because the polygon BP is a vector 2 array. So this is a vector 2, and we can calculate with vector 2. So you can just sum them up, and then the x's are summed up and the y's are summed up. So I can sum it up with the polygon offset that we have determined here. So with that offset and this transform together, we have the right location. Now once we have that right location, for each of these polygons in this tile, we're going to create a new add outline, and we're going to add the new polygon. And then we take the whole polygon, so that will be this right here, the same function as we have here, and we make the polygons from the outlines, and we set that polygon to the navigation polygon instance. Now, with all that done, that's a lot of code. Maybe replay it again if you have to, but once you got that all down and you play the game, all your shapes from your chests are cut out, and if you run any sort of navigation pathing, your characters or objects that you're moving with the Navigation2D node, they won't be bumping into this collision shapes anymore. Now, with that done, there's one thing I still want to tell you, so let's move straight into that. So, right, you think, okay, this is great, this is awesome, I'm going to use this everywhere. Well, hold on. There is one rather big limitation. So this is not perfect. And the reason that it's not perfect is the reason, oh, that's a little bit too big. The reason is why I've made this cutout for this entire river system. Because you would think that why would you need this whole cutout? You can just go over the collision shapes that are on all these water cliffs. You can just cut out the collision shapes of all these water cliffs. Well, I tried doing that, but then I regretfully ran into errors. The problem is that because these tiles, they are exactly together, that if you use the coalition shape, it means that one of the points of, let's say, this coalition shape and this coalition shape, they're going to share a vertex right there. That's the same. And the navigation polygon instance cannot handle that two different cutouts share a single point in their outline together. It cannot handle that. It doesn't know how to draw that, and the error gives back a error code. Actually, not in the editor itself. In the editor, you just don't see anything. But maybe we still have one of these. Then you basically get this error here: the convex partition field. Now that error doesn't even show up in the editor, it only shows up right here, but then you pretty much know, like, okay, things are not working the way I would want them to work. So there is a limitation here. So you can use this code perfectly well for like individual tiles, like trees and buildings, like I said, that are all over the map. Of course, when you sort of move two rocks inside each other, you'll run into exactly the same problem, as the navigation polygon instance wouldn't really know how to draw that. But as long as these are individual tiles, and maybe in your map design, if you want to use this approach, that's not really an issue. Like maybe if you take this into account in your map design or in your asset design, you can make sure that everything works as intended. So yeah, there's a limitation there. So you would still have to draw out the big polygon instance based on the contour of your map, like around river systems, around mountains maybe, but anything other than that, like singular objects, static objects, these are perfectly able to cut out in bulk, and it's actually really fast. So yeah, that's like a small limitation. It's definitely something I wanted to show you. Then there's another thing I want to show you, and that is a feature that's going to come out in Godot 4.0 that's going to make this code completely redundant. But yeah, 4.0 is like 8 months from now or something like that. But there is something pretty cool that is going to be happening in 4.0. So let me give you a quick peek on that. That was a pretty recent news, and then we can all dream and be excited about the future. Let's get into that. So in Godot 4.0, they got something really awesome coming out. It's called NavigationServer. Basically, it's going to give us new nodes like the NavigationServer, NavigationServer2D for 2D games. And basically what this is, well, we got some videos, don't worry. We're not going to go over the code. We got more than that. We have enough code for now. So this is basically like the navigation, and it's navigation to this edge, but this is its goal, so it cannot find that, but it will try to go as far as possible. And then what's possible is that you can add at runtime, add a ramp, for example, here, and it can bake that navigation mesh at runtime, and then the navigation nodes can use that. And even when you got moving sections, the player, as you can see here, it will slow down until it comes up with the cheapest tile. These are like tile costs, and then it will go over there. And even with agents, so here you get a whole bunch of agents like enemies or whatever, or objects, and it can even slow down and navigate through that, and then wait until the ramp is added, which is all baked. That navigation mesh, the navigation polygon, is all baked at runtime. So that looks really cool. This is going to give us a lot more options when it comes to smart navigation inside Godot. So I'm super hyped for this. Regretfully, it's going to take like another 8 months before this will be out. So I hope until then that the code and the tricks that I've learned you today are going to be serving you well and getting you the results that you're after. And yeah, if not, or basically both of us, you and me, we're both going to be waiting for this to come out in the end of 2020. That was it for today, guys. Hope you like it. If you did, smash that like button, hit subscribe. Don't forget that little bell icon to make sure you don't miss out on the next video. Now, as always, I should live stream my own game development sessions that I'm working on my own title, Soul Whisperer, every Tuesday and Thursday. So you're welcome to come and check that out. We also got a new Discord server up, so if you want to hang out with other Godot developers, ask some help, ask questions about these tutorials or game development in general, you're more than welcome. Links to all of that is down in that description box below. I hope to see you on the next tutorial, and until then, keep on gaming, keep on coding. See you later, guys.